morning, everyone. My name is Dr. Charlene Ortiz, and today we are going to be covering the lecture of research in psychology. Why do we need research in psychology? What types of steps are involved concerning psychology and the research method? We're also going to be covering different types of research, for example, correlational research and experimental research, and perhaps we're going to have time to cover non-quantitative methods, so for example, qualitative types of research. So today we're going to be focusing on that type of lecture. So let's get started. All right. So one of the first things that I would need to discuss with you guys are the goals of the scientific enterprise. So whether you are in the hard sciences like physics and engineering, or if you want in one of the soft sciences, so for example, history and social sciences, things of that nature, we all have the same goals when it comes to scientific knowledge. And the aspect that I would like to mention about that is that we have three sets of goals, right? We have three main goals. And the first goal that I want to talk about is measurement and description, right? If you come across an engineering difficulty, the first thing that we will need to do is need to measure it. And it's no different for the social sciences, right? We need to develop measuring techniques, right? So that's how we come across measuring. We can't measure something at random or have it be that is based on a biased assessment, right? So for those of you who are in engineering, if I have a ruler and this ruler, every time I measure this table, it's 40 inches, but then in the same ruler, I give it to somebody else and the table measures 51 inches. We know that that's not a reliable measure, right? So we need to develop techniques that make it possible to have reliable and valid measurements, because without it, imagine if it's so difficult to measure this table, imagine how difficult it would be to measure behavior, right? Which is much more complex. So that's one of the main interests that we have in regards to trying to measure a phenomenon that's under the study. The second goal that I want to talk about is understanding the phenomenon and predicting the phenomenon. How do we do that, right? How do we go about understanding and making a prediction? The first thing that we do, we have to develop a hypothesis. We like to make hypotheses because we are able to test a prediction. A hypothesis is simply a prediction of a relationship between two variables or more. So for example, a hypothesis can look like when A happens, B will occur. If A doesn't happen, or if A increases, B is going to decrease, right? So that's a hypothesis, because I'm trying to make a prediction. The closer we are to final exams, the more performance anxiety we're going to see in students, right? That's an example of a prediction. If I heat this piece of metal in a certain way, the piece of metal is going to extend. Right? The more temperature, the more expansion, right? So notice that a hypothesis is used to predict, right? And that's not different in social science. Now, another thing that we need to understand is variables, because before we can make a prediction, we need to understand what a variable is, right? What's A, what's B? A variable is simply something that varies. It's simply something that can be indeed measured. And that could be anything, right? That could be absolutely anything. So for example, it could be an event. It could be a characteristic, a behavior, basically anything that you are trying to observe and measure that we believe is going to have a change. So for example, those of you who are in sports here on campus, the closer you are to the big game, the more likely you are to have performance anxiety. That's a prediction. We would have to therefore define what a game is. That's the definition of a variable. Is it hockey? Is it tennis? Is it chess? What's the sport, right? And we will have to define what performance anxiety is, right? So it's my responsibility as a researcher to define those variables. Because if I am not able to define that variable, I can predict upon it, right? So for example, the example that I gave you about this table, right? You're measuring the table and it's 40 inches. So what's a table? A three-legged table, a desk where you're sitting right now. And that's important because we can have some sort of consistency throughout the measurement. And the last thing that we are concerned with in regards to science, the goals of trying to conduct some research is the application and control. Application and control. And what do we mean by that? In regards to application and control, what I mean is how practical, what is the value in studying this topic, right? What type of application can I come across? Can I solve? And I ask these questions. Can I solve a problem? Can I address a problem through my research? So in keeping with that example of engineering, if we know that we increase the temperature, that piece of metal expands, say there's a problem in the structure of that building. So your research will have some application and some practical application to a real life problem. And in psychology, it's the same thing, right? So when we are studying a behavior, an event, we want to ensure that our research actually has what I like to call roll up your sleeves in-depth application later on in real world practice. One way to do so is through a theory, right? And a lot of you may use the term theory incorrectly, and that's fine because when we are in the greater community, we tend to think about a theory as a guess, right? So I have a theory that Peter is going to fail the class. I have a theory in how to play the stock market. I have a theory in how to invest in gold, for example. Notice that when we use that term, we're using it incorrectly because generally we're referring to a guess. Now, a theory in the scientific sense is a system. It's a cluster of ideas and evidence and research and laws that have been put together in order to provide an explanation of a certain phenomena, of a certain observation. So notice that a theory is not a guess, right? A theory is simply a system, a group of ideas that we're going to use in order to provide an explanation. So for example, when we think about the theory of evolution, this is a set of data that we have in order to make or have an explanation as to why species adapt to their environment. Notice that we're not referring to a guess, we're referring to a system in order to explain a phenomenon. Because of this, when we integrate these facts and these principles that we have in this theory, this allows psychologists to go from a description to an understanding, right? So now I'm just not merely describing something, right? This room is white, right? It has a white ceiling, it has blue and gray floors. So I'm going beyond that. I'm not just simply describing, but now I'm going to understand how is it that this room is so light. So I'm going to move forward, step forward. Any questions about that? Something really important to note is that even though it is a system based on evidence and logs and pieces of information that we have to provide an explanation, I do want you to keep in mind that theories can always be revised. Right? They are always ever expanding. We always come across new research. And I'll give you a good example, right? If you talk to your buddy, the biologist today, you know, you have a friend that's either a biologist or someone who is studying biology. If you talked to this person about the theories and understanding that we have about biology today, Compare it to what a biologist would have said 2,000 years ago, 3,000 years ago, right? So notice that theories do indeed change and adapt. In order to reach these three goals, we have different steps in the scientific investigation. And in these steps, it's generally 6 steps, I should say. What makes it a scientific investigation is because it's systematic. There is a process, there is a procedure in order to conduct a scientific investigation. And this applies to any branch of you guys, engineering, nursing, anything, any sort of science, hard or soft science. The first thing is that we need to formulate a testable hypothesis. And what do I mean by a testable hypothesis? Remember that earlier I mentioned that a hypothesis is a prediction, right? If A happens, if A increases, B decreases, if A decreases, I should say, B is going to increase. But sometimes people can put forth predictions that cannot be tested. So how good is that hypothesis? If I cannot reject this hypothesis, if I cannot test this hypothesis, it's not good. And I'll give you an example of a poor hypothesis. Prove to me that there isn't a pink elephant in the room. That's a negative hypothesis. But we can demonstrate or reject there is a pink elephant in the room, there isn't a pink elephant in the room. This one is testable. This I can actually test, right? Through observation, to surveying, taking a head count and say, well, we're missing a pink elephant, right? So a hypothesis is only as good as it can be tested. How do we test a hypothesis? The first thing that we need to do is conduct an operational definition. And the meaning is in the term, right? So an operational definition is simply, we're going to describe this term, this variable, we're going to describe it in the sense of which operation are we going to use to measure it. So for example, I think I might have said this in the previous class. If not, it's a new example. If I were to ask, say, we're going to do a study about love. We're going to do a study about romantic love. So if I asked you to define romantic love, how would you define it? Okay, so she defined romantic love as an extreme level of trust. What about you, sir? How would you define romantic love? Is there no romantic love?
Probably as feelings of infatuation mixed with, like you said, like trust and a certain level of codependency.
Good. So she defined it as a level of trust. He defined it as infatuation. Anybody else wants to share the definition of romantic love? Anybody else? Pick somebody at random. Let's see. Yes, ma'am.
As an emotion.
Okay, so romantic love is an emotion. Notice that just with 3 people, we have 3 separate definitions of romantic love. How am I supposed to test it if I have 3 different definitions? So that's why it's so important to clearly conduct an operational definition for a term. If I cannot define it in a consistent fashion, I cannot test it. So is it trust, is it infatuation, or is it an emotion? Right? So that's where the scientist comes in and will make a determination of how am I going to define this variable, operationalize this variable in order to measure it for my study. And that's just with 3 people in one classroom, in one town. Imagine if I tried to do that, say, in the greater Alabama area. How good would that definition be, right? Any questions about operational definition? All right, good deal. The next thing that we would like to do is we're going to select a research method and assign. Now, covering the scientific steps within this course may be out a little bit outside of the scope of the course. So it's really brief, the definitions that I'm providing. If you want more detailed information, I do teach the course after this one, the more advanced course, and then I teach actual research. Then people who like them stats, right? So I actually teach that course, and we go really in depth in these terms. Now, what's one of the more important things about the selecting a research method and design? Well, firstly, we need to find out who our participants are. What are participants? Participants are persons or animals, right? So with individuals, with persons, we usually refer to them as participants. And with animals, we tend to refer to them as subjects, because a person can't consent. A person can say, yes, I will participate willingly and voluntarily in your study. An animal cannot. So that's why we don't call them participants, we call them subjects, because they cannot provide consent, right? It's a little distinction that we like to make. A participant is simply someone or something that is going to be part of our study, and we're going to define what that participant is, and we're going to systematically observe that participant or that subject. So we're going to have to define that population. And an example that I gave in my research class was, let's conduct a study about romantic love in undergraduate engineering students, right? That's an example. So what's an undergraduate engineering student, right? I will have to define who that participant is. Is it first year? Is it everybody? Is it people about to graduate? Is it people who are only taking courses online? Right, so I would have to define that, because that definition can impact how I draw that pool of participants, right? I'm going to collect data from those participants, which takes us to our third step, right? Look at that, full circle, doing that segue over there, hashtag segue, right? So what we're going to talk about now is, how do we collect data? And what's data collection? It's basically the procedure through which I am going to gather empirical observations, right? I'm going to conduct a measurement. So in keeping with our example, right? Keeping with our example of romantic love in engineering students. Say I defined what undergrad engineering students are. I operationally defined what romantic love is. So how am I going to gather that data? Right? Is there a difference between undergrad engineering students and their romantic love versus, let's say, sociology students and their romantic love towards their partners? Right? So I can determine if there is already an assessment that measures romantic love. So I can use that in order to gather that data, in order to collect that information. Any questions so far? Fantastic. Fantastic. Now, remember, if we keep with our goals that we were talking about, it's not simply to describe data, right? Our goal is not simply to describe data, although there is significant importance in describing data, and you will see that in qualitative research later on. But the next step is not just to collect data, it's also to analyze data. We have to draw this information. We can say questionnaires, we can say interviews, psychological assessments, we can say physiological recordings, which is something that we do in fact in psychology, for those of you who didn't know. People forget that sometimes our subjects can also be records, right? We can do an assessment based on historical records. So sometimes we don't even need people at all. But it's only as valid as I can draw conclusions for my research, right? So let's say I conduct my study and I compare sociology students with engineering students and their romantic love. And I would say the prediction would be, the hypothesis would be, students who are in the sociology department, undergraduate department, will express more romantic love than when compared to the group of engineering students, based on the XYZ assessment inventory. That sounds like a sound hypothesis. And say we conduct the data, we gather that sample, we draw the participants, we gather the assessment from the participants, and it turns out that my hypothesis, I reject my null hypothesis, which is there's no difference. And my alternate hypothesis would be, yes, there was a difference. And not only that, sociologist students would score higher. Well, that's fine and dandy, but what does that mean? Right? I'm simply describing, yes, there was a change. I found out, yes, there is a difference between the two. So now we have to describe, we have to analyze the data further, right? We have to come up with new information based on the results. The last thing that we would like to do is we have to report our findings. That is because there's multiple reasons why we have to report our findings. One of them being that our information, especially in psychology, I like to refer to psychology as a popular science. I like to refer to it as a science of the populace, as a science of the public, right? Because a lot of the information that we utilize doesn't stay, say, for example, with the building, right? So it applies to a population, right? So in engineering, for instance, we have information that goes towards, hey, we're going to build this building. But I like to refer to psychology as the science of the populace. And that has its advantages and disadvantages. Mainly that people may misdiagnose or things of that nature. But we do have to report the information that we discover. One of the reasons is because it's shared with the public. Another aspect that requires that we share our information is that it allows for our peers to evaluate our data. What do I mean? Say I conduct this study and it turns out that not only is there a difference in romantic love between sociology and engineering students, let's say I publish this research. And the point of that is someone who is my peer, someone who knows about psychology, who's a doctorate in psychology, and it's a researcher, they should be able to try to do my study in the same way and come up with the same or similar results. If that doesn't happen, there could be deception and malice on my end, okay? Which would be the worst case scenario. Best case scenario, I made a mistake, right? A statistical error or an error in collecting my data, drawing my participants or my subjects, whatever that case may be. I will tell you when you do submit an article for publication, it will be rejected 90% of the time because the process is tedious, process is immensely difficult. But that peer review process, the ability for people in my field to evaluate my research and try to discredit it is actually good because only the best and most sound research will get published. That doesn't mean it's perfect, right? That doesn't mean it won't have flaws. But the good thing about that peer review process is that we can at least increase the probability that this research was sound, there was less indication that there was malice or deception. So any questions about that? So why is the scientific approach good? Why is it that we tend to use the scientific method? One of the things about the scientific method is that it must be clear and it must be precise. It requires that you are specific, right? It requires that you are clear in what you want to say. And all of you can relate to this idea. Think about the smartest person, right? The smartest professor, or the smartest teacher you ever had. And sometimes they can be the smartest person that they cannot teach. Their message does not come across. And I'm sure every single one of you has come across that idea. Well, that is because, sure, you have the information, but you're not clear. You are not specific about what you're trying to teach, right? In my case, I try not to ramble. I'm trying to stay on point, move around a lot so that my message is clear and it's direct to you. Something interesting when it comes, and it's an advantage of the scientific approach, is that there's little room for error. I'm not saying there's no room for error. There's very, very little room for error. There's very limited tolerance for error. That is why you will always have a supervisor. You will always have a group of peers that's going to look into your work. Not only that, once you submit it, there's going to be a group of your peers in that publication that their sole job is to discredit your research. If they cannot do that, generally it will be published because it is sound. Generally what happens is if it's good, they'll ask you to make a couple of revisions. But remember, it will be rejected about 90% of the time. Most people don't get it the first go. Let's say that. And that's a good thing because there's no room for error. We try to minimize error. The problem is that you may think, well, that sounds a little tough. Nobody's perfect. And sometimes we rely on other methods. For example, common sense, right? Well, it's common sense, right? So it must be good. The problem with that is that just because something has common sense, it doesn't make it accurate, right? And I'll give you an example, an old adage, and say, if it quacks like a duck, walks like a duck, right? Must be a duck, right? Absolutely not. It could be a robot. It could be a plush toy. It could be somebody dressed as a duck, right? So that was room for error because it could be so many things other than an actual duck. It could have been a geese. It could have been a goose, right? So notice how in the scientific method, we have to go beyond common sense because common sense is not enough. Common sense has a lot of room for error. So that's why we move towards the scientific approach. Another advantage of the research method is that, of the scientific approach, I should say, is that it has research methods. And of course, if you want more detailed information about, we're going to cover some of them here probably today. So one of the things about the research methods is that there's different approaches to observe a phenomena, right? Sometimes the statistical approach is not accurate, or I should say adequate to view and understand a variable. Sometimes it's not the best method. Sometimes we actually just only need a description. And sometimes doing the statistical procedure, it's not necessary at the time. Maybe we need an in-depth description. So research methods allow us to provide, I should say, an observation, a measurement, manipulation of these variables. And we don't have that in common sense, right? Because you quack like a duck, walk like a duck. I don't need to conduct any further observation or measurement in order to determine whether or not this is indeed a duck. Any questions about that? Good deal. Fantastic. In keeping with the research methods, one of the first things that I like to talk about is an experiment, right? What makes an experiment, right? An experiment, it's simply, well, first of all, it's one of the more common ways to conduct an investigation. And what makes an experiment an experiment? The main and most important factor in an experiment is that I will be able to manipulate that variable. I will be able to manipulate that variable. What do I mean by that? Let's talk about, say, we're going to conduct an experiment regarding this brand new medication, and this medication is geared towards reducing anxiety. So this is a brand new medication. My variable, my independent variable, and keep in mind that the independent variable is that you can indeed manipulate. So that's an independent variable. So I want to conduct a study where I have this medication and I'm going to give it to persons who are experiencing, let's say, schizophrenia. It's brand new medication for schizophrenia. The independent variable in this experiment is the medication. And why is it the medication? Because I can indeed manipulate that variable. I can determine how many pills you're going to take, the dose, when you're going to take it. So I can indeed directly manipulate that variable. So that's the first characteristic of an experiment. I can indeed, as the researcher, manipulate that independent variable. The second characteristic is that whenever we are conducting that manipulation, we want to be able to observe and measure if there were indeed any changes in that second variable. What do I mean? What does that mean? Let's keep on with our example. I have a medication for schizophrenia, and I have persons who have positive symptoms of schizophrenia. So for example, seeing things, hearing commands, right? Those are positive symptoms. Negative symptoms would be for that person to become reclusive. So basically positive is adding, negative is taking away, right? So the person starts hiding. But this medication is only interested in positive symptoms. The independent variable is manipulated, and the dependent variable in this case is going to be those symptoms. I can manipulate the independent and I can measure the dependent variable. So I can manipulate how many milligrams you have, and I can measure the intensity of those symptoms. Right? So the dependent variable, that changed. Whether you have same symptoms, more symptoms after you take the medication, or less symptoms after you take the medication. Or perhaps intensity. Have these symptoms, and you start taking the medication, maybe they became really active, or maybe they started receding. So notice that I can indeed measure that dependent variable. So independent variable is manipulated, dependent variable is measured. Now, perhaps one of the most important factors when it comes to a experiment is experiments are designed in this fashion. I want to measure, or I should say, manipulate an independent variable to measure that dependent, because I want to be able to explain a cause and effect. I want to be able to say, yes, indeed, this medication, in fact, reduced the positive symptoms of a schizophrenic patient. That's one of the main advantages of an experiment. It allows for the researcher with a certain level of certainty. Generally in social sciences, it's 95%. In hard sciences, it's 99%. But generally, it allows that researcher with a certain level of certainty, I should say, this medication and nothing else with a 95% of confidence was what impacted the decrease of symptoms, this dependent variable. Any questions about that? Good deal. Now, something important about an experiment is that in order for us to be able to say, yes, there was a cause and effect, I want to be able to say that that dependent variable, right, and the participants that are in, first of all, had the opportunity, everybody in that population that I had defined previously, as you recall, had to define that population, like I said. Is it only going to be undergrad students, first year students, going to be online students in engineering? I want to be able to say that not only I grabbed these participants at random, but also that I assigned these participants at random to my study. Because let's say, in keeping with our previous example, I say I'm going to give an equal chance of participation to sociology students, and I'm going to give an equal chance of participation for my engineering students. We'll say that I know a couple of sociology students and I know they get really well with their partners. That wasn't random, was it? In order for me to measure their romantic love, because I already know that they are good people with their partners. So if I start grabbing these individuals, my experiment or my assessment is going to be biased. I want to be able to show that I had an average collection. It was normal. It wasn't skewed. I didn't grab just students that were doing poorly in romantic relationships, or that I grabbed students that were doing great. I want to be able to show that it was indeed their degree, for example, sociology versus engineering, that had an implication towards that dependent variable, which in this case would be romantic love. Any questions about that? Fantastic. Fantastic. How exactly can I say, well, it was indeed because of this medication? Right. This is where we can find our experimental and our control groups. So an experimental group is that group that receives that treatment, that receives that independent variable, right? So going back to our example of a piece of metal, I would like to say the piece of metal that I exposed to that heat would be the experimental group. A piece of metal that didn't experience that heat to see if it would expand or contract, that would be a control. That will be a control group. So notice that the group that experiences the treatment, that experiences that independent variable, that is the group that we like to refer to as the experimental group. In contrast, the group that does not receive the treatment, i.e., the group that didn't receive the medication, the group of people, and the group of pieces of metal that did not receive that heat, that is what we consider a control group. The subject, the participant, did not receive that experimental variable, that they didn't experience that independent variable. Why is that important? Well, because I want to make sure, and I want to increase the chances to demonstrate that that heat was indeed what caused the expansion of that piece of metal. I want to ensure that that medication was what increased or decreased those positive symptoms of that schizophrenic person. I want to be able to compare it to what I like to call the baseline. And the baseline would be not receiving any treatment whatsoever, right? Not receiving heat or not receiving that medication. Any questions about that? Fantastic. So before we go over here, I'd like to talk a little bit more about disadvantages of experiments, because so far it sounds great, right? It sounds okay. I'm controlling for my variables. I'm exploring effects, right? So far it sounds really great, but there's actually disadvantages to the experimental approach. One of the disadvantages is that it's highly artificial. It's highly artificial. And what do I mean by that? Well, generally, when we are, especially in social sciences, right? And even in engineering, right? And keeping with that piece of metal. When you're in a laboratory conducting a study, whether it be with a real life person or that piece of metal, that environment is controlled. The temperature is going to be the same. It's going to be 70 degrees, right? So there are other variables that could account, say, for example, for the expansion of that piece of metal or for the romantic love of those two groups of students. So it's highly artificial. Right? So it comes at a cost that is so controlled, right? Because it's highly artificial. We're not observing variables that could be impacting, say, the expansion of that piece of metal, or in social sciences, perhaps, the romantic love that those students are having with their partners. So any questions about that? There's another disadvantage of experiments. And this is what we like to call extraneous variables. And what is an extraneous variable? Is any other variable then, just like that independent variable could influence what we're trying to measure, right? It's going to influence that dependent variable. So let's keep with our example of the patients, right? The schizophrenic patients with positive symptoms, and we're finding out this brand new medication. We're trying to study it, see if it actually decreases symptoms. We have our independent variable, of course, which is the medication. And I say, you're going to take 200 milligrams. Excuse me, you're going to take 200 milligrams. An extraneous variable would be, maybe that person didn't eat dinner that night. And as you know, a lot of medications are impacted whenever you eat or not eat, right? Say, for example, how effective they are, or how fast they take care, bless you, how fast they take care of symptoms. So that could be an extraneous variable. I'll give you another example. Let's go back to our example of romantic love and my sociology and engineering students. Maybe that day, we're going to do an assessment about romantic love, and you show up, sure, I want to participate, but then that morning you had a big old fight with your boyfriend or girlfriend. How do you think you're going to score your romantic love that day? Probably very unfavorably. So that was an extraneous variable. I simply could not control that. That was outside of the experimental area. So if you had a big old fight with your boyfriend or girlfriend or spouse or significant other or whatever, what's another one? My boo, whatever it is, that person that it is to you. If you had a big old argument with that person that morning, chances are that variable, that dependent variable of romantic love, I'm not going to be able to measure it accurately. That's what an extraneous variable is. A confounding variable is very similar. But what I like you to think about a confounding variable is that it is linked to that independent variable, right? So it's affecting my independent variable, right? And I'll give you an example in keeping with our medication. participant gets to experience, we go back. Therefore, because I cannot control for all those factors, I cannot say that it was a cause. I cannot say that one variable caused the other, or that it impacted the other. And I'll give you a funny example, which is true. It's actually a true example. The larger the shoe size, the better the test performance. That sounds crazy, doesn't it? This is a true correlation. The larger A, larger B, the larger the shoe size, the better test performance. You're thinking, How is that related, right? Imagine, the average shoe size for a college student, let's say, is size 10. The average shoe size for a kindergartner is very small, isn't it? So if I give a kindergartner a calculus test, he's not going to perform well. But if I give you a calculus test, you'll perform better than that kindergartner. Some of you say, nah, I don't think so. I would hope you would perform better. So notice that there is a correlation between shoe size and test performance. But the shoe size didn't cause the test performance, did it? It's simply a correlation. What caused the test performance was education. That was what we like to call the Z factor. That's why a correlation, despite on how good that correlation may be, you find a really strong relationship between shoe size and test performance. That doesn't mean it caused it, did it? Because in this case, it was education in math that caused that test performance. That kindergartner probably doesn't know how to add 2 + 2. But you, as a college student, we would expect that you would perform better in a calculus test. In these associations, these relationships that we have, there are 2 types of correlation. The first type that we're going to talk about is a positive correlation. Now, what is a positive correlation? A positive correlation simply indicates that when one variable goes towards one direction, the second variable will go that same direction. That's all it means. Doesn't mean if it's good or bad. It doesn't mean if it's less or more. It simply means that one goes in the same direction, as the other. So in keeping with that, here we go. So a positive relationship would be when A increases, B will increase. When A decreases, B will increase. Notice that I'm not talking about good or bad, plus, adding or subtracting. I'm only referring to positive simply means that it's going to go the same direction. So both of these variables went up, both of these variables went down. So what's a negative correlation? A negative correlation is that when the variables will be going in opposite directions. So if A goes up, it's a negative relationship, which means it's opposite. And B is going to go down. Vice versa. A goes down, then B will go up. So let's give you an example about that. Let's think about the example that I was giving you about the psychiatric patients. The more milligrams they take, the less symptoms they're going to experience. That is a negative correlation. The more A, the less B, right? That would be an example of a negative correlation. The more Tylenol you take, the less headache you're gonna have. Although don't take too much Tylenol, and then that's gonna be a positive. It'll turn to a positive relationship real quick, right? It's gonna be the last headache you ever have. So notice that the more medication you take, the less likely you are to experience these symptoms. That would be an example about a negative correlation. A positive relationship would be the more you study, the more likely you are to pass the test. The more you study, the more likely you are to pass the test. Any questions about that? Yes, sir.
What do you call it if the correlation changes, as you said, like past a point, then it becomes positive? Or but basically, yeah, what if past a point the correlation changes?
The correlation, when I mean that, say for example, and I'll draw some, I feel artistic today. Where are my artists at? Anybody in art? Got a couple. All right, look, you're gonna grade me today. Look at this curve. What? Look at that. It's let me share the screen. So what happens then is we want things to be normally distributed. We want everything to be basically in the middle. If we start moving, so this will be the adequate amount of milligrams, right? This is a little bit more advanced, but we'll leave it at that. This is about 68% of the time for the people who would take this medication at this level and will feel better. But then if we start putting, I don't know, say 300 milligrams, we start seeing how that relationship is moving way further from what the norm would be. So that's why that occurs. So here, say, was 50 milligrams, here was 300 milligrams. So notice, instead of being in the optimum, now this curve, instead of being normal, it's going to be skewed. It's going to look more like this instead of like this. So basically, your distribution, say for example, for the symptoms, would be skewed. So it wouldn't be a normal distribution.
So basically, if the correlation changes, it's just the results get a little weird.
Skewed. It would be skewed. How was my curve? Did I do well? I didn't do well, did I? I tried though. I tried to draw it over. Any more questions about that? All right, fantastic. I know a lot of you didn't sign up for psychology. It's like, there's math in this class. I know. I'm sorry. I'm sorry. Now, let's talk about correlation and characteristics of a correlation. First, let's talk about the correlation coefficient. So what do I mean by correlation coefficient? This is simply the amount, or we can also call it the degree of relationship between one variable and the other. I like to refer to correlation as the strength of that relationship. So strength of this relationship here. And what does this look like? Well, generally, if we were to draw a little line, right, positive and negative, very simple. We have our -1 here, and a positive 1 here, and this here would be our 0. The closer we are to either -1 or +1, the stronger that relationship is. So if I have a relationship between, let's say, 0.86, -86, or a relationship -50, this relationship is stronger than this relationship because it is closer to that -1 value. Like conversely, you know, if I have a +50 or positive 0.50 or 0.86, notice that the closer they are to that 1, the stronger that relationship is. And remember, we were talking about a negative number. So what does that mean? It's a negative relationship. Talking about a positive number, it's a positive relationship. So both increased. We got this number. One increased, the other decreased. We get a negative symbol. So the symbol indicates the direction, whether up, up, or up, down. And the number simply indicates the strength. How strong is this relationship? So we can infer this relationship is stronger than this relationship because it is closer to that point. Any questions about the strength of a relationship between variables? Yes, sir.
Is it like mathematically determined or is it yes?
Oh, no, there's a lot of math. It's just, it will be outside the scope of this class for once. Are you in psychology? No. So in psychology, generally, you will have to take statistics first, generally a year, and then you have to take experimental psychology. Then you will have to take, let's see, research, which is the class that I teach. There's multiple ways to determine correlational coefficients. We have cohency, that's a form of statistics that we can run. And generally, correlation coefficients are expressed with the letter R. So, not a capital R. So if you want to look more into that, do a VA. Arm, you can do open C, that's another way. D, also, it's not a guess, it's scientific. Yeah, we have to use the scientific method in psychology, so nothing can ever be guesswork. Yes, ma'am.
So just so it's still a positive correlation if both variables are,
So it's
if they both go down.
if they both go down or they both go up, right? This is a positive relationship because they're going the same direction. But if you have any sort of different direction, like this, so one went down, the other one went up, this will be considered a negative relationship. Yes, ma'am.
And the correlation is just the number that represents how strong will be. So like,
Yes. So what he mentioned is, I want you to remember the symbol implies the direction and the number will imply strength. The closest they are to positive or negative one, the stronger the relationship would be. And if you want to know, oh, which direction? Well, positive or negative. Any more questions? Yes, sir.
Here, the correlation coefficient is 0.
Fantastic, you're absolutely correct. If you were to find, I think you do have an example here. We don't. Let me see if I can go one very quickly. So when we have and this is how it will look like statistically, by the way. So let's see that. Excellent. So whenever you're running your statistics, I should say, notice how here we have a linear pattern of your data. Of course, this is just an illustrative example, so it doesn't have any numeric values. But in keeping with this, here this is a positive relationship because the more X increase, the more Y increase. So you start seeing how each value heads towards this direction. So this would be the more medication the person takes, the better the symptoms. And now here we can talk about, or let's use romantic better. The better the relationship, the better the romantic value. Here we can think about the medication. So here we can say the more medication they take, excuse me, the more medication they take, the less symptoms they have. So notice how it starts going down. Right? And then here, this is what a no correlation looks like. So whenever you run your R value statistically, you'll see that the plots are scattered just all over the place. There's no real direction. Whereas here, they seem to conglomerate closer to this line. Now, this line actually represents that one that we were talking about. The closer these dots are to that, these values or these pieces of data are to that line, the closer they are to that correlation, and therefore you would say, okay, it's going towards a positive relationship, going down, negative relationship, or no relationship. These values are all over the place. You have a 0.50, point negative 40, and then you have a 80. So notice how all these plots are going to be scattered. Does that answer your question? Now, in other courses, you would actually be running these statistics yourself. So if you're in psychology, it's common. It's common. All right. Now, we've been talking an awful lot about statistics, but we also have other methods of gathering data. What would that be? Well, we have qualitative measures. One of those qualitative measures is naturalistic observation. What's naturalistic observation? Well, first of all, it's a qualitative research design. It's a research method. It's qualitative. Qualitative sounds an awful lot like qualities, right? So the point of qualitative research is to describe qualities, right? Whereas quantitative research, which is what you just saw earlier, the intent is to quantify. So that's why you see so many numeric values. In a naturalistic observation, what are we doing? Well, definition, it's in the term. We are trying to observe behavior without intervening with the subject at all. So I like to call that watching you in the wild, right? Watching the subject or the animal or the participant in their natural habitat without their knowledge. Right? People are like, well, people do that. They do that. So for example, let's think about a child, right, who is performing poorly, has a lot of behavioral problems, is getting in trouble in school. So a naturalistic observation would be to observe them in the classroom, in school, in the playground, without his knowledge. So he's able to perform naturally. That is why it's called a naturalistic observation. We are observing you in the wild. The good thing about that is that it allows us, as I mentioned, qualitative research describes qualities, right? So it's descriptive, not statistical. The good thing is that the great advantage is that we get to see things as they occur. And if you remember from our quantitative aspect, right, research, we talked about how it's very artificial. This is as real as it's going to get, right? Now, sometimes the participant can become aware of your presence, i.e., you guys are sitting here, right? And if I walk outside, you know, maybe you have a few things to say about me. So that's you and the wild. But the second I come here, like, oh, she can hear me. So you're going to change the behavior because the observer, you have become aware that the observer is present, right? So your behavior can't change, which is why it's so important that the participant is not aware. Reactivity, therefore, is when your behavior changes because of a presence of that observer, right? So say before you were headed here to class, you were doing, 70 on 25 because you didn't want to be late. That's you and your natural behavior, right? But then you see little lights flashing. Oh, that's an observer. Maybe I need to alter my behavior. That's reactivity. Yes.
How do you effectively observe stuff?
So and that's a good question, because sometimes we can be observing behavior that could be considered, wow, that's drawing a line. Generally, we don't use identifiable information. So I can say something, white male in his 20s. That could be any one person, right? But I'm not going to say something like, is this guy that walked into his house and lives in so-and-so street. We wouldn't use identifiable information. So that person's identity would be at risk. I'm sorry?
We're at 5 minutes.
5 minutes, okay. Are there any questions about naturalistic observation? Something really difficult about naturalistic observation is because the fact that it is natural, we can't translate it into statistical data. You could conduct an experiment later and conduct statistical analysis on the observation, but that's one of the downfalls. All right, and that brings us to the end of the class. I'll see you next week.